Hello, we're going to talk about 11R, the intersection of three planes. And there's a few situations that can happen. The first situation is, I like to think of it as the corner, right? You got three planes. You got a plane right here. You got a plane right here that's, these are the two walls. And then here's the floor, right? Well, in this situation, they're going to intersect at that point. So you're going to be able to find out a solution x, y, z for the coordinate point, right? But then three planes can also, as I've drawn right here, intersect at a line, right? You can see this plane, and this plane intersect at this line, so that can definitely happen, right? And we can come up with an equation of a line. It could be parametric, it could be a vector equation of a line, it could be Cartesian, right? So the three ways we know how to draw, represent lines in 3 dimensions, right? But also planes, we can have planes that not all three intersect, right? These two planes, if this is plane 1 and plane 2, make it a little plane 2, right? Those intersect at this line. But plane 3 over here, if this is plane 3, they all don't intersect. Now these two intersect at this line, and these two intersect at that line, but there's no common intersection. So this would be no solution, or sometimes they'll refer to it as the empty set, right? Well, even though they intersect here, we also have other situations where they don't intersect, right? And these would be these other ones where we could have parallel planes, but one plane intersects them, right? This also is no solution, but we can also have all three planes that are parallel, right? About the parallel planes, what could we say about their normal vectors then, right? No matter what, they're normal vectors that are perpendicular to it, right? That would go through here, right through here. Good. Their important concept is that they're normal vectors, right? If this is the normal vector that goes through it, their normal vectors would end up from this plane right here to this plane right here would end up being parallel, right? And the same thing with these guys. If we have the normal vectors going through it, we would know that their normal vectors would all be parallel. So those are some concepts we're going to look into. So let's go ahead and look at an example, right? First one, example 48, it says consider the planes defined below. Show that the three planes intersect at a point, right? So I can see from here, and this is going to be nothing new that you've done before, I'm going to find the coordinates of their intersection point, right? And we're going to do, elimination, right? And I can use this top equation to eliminate the bottom by just adding it. Well, I'm going to keep this first equation the same. So I'm going to have x plus y plus 3z equals 5. And I can get a new equation by adding these first two together. That the x's cancel. I'll get 3, let's write this, 3y. And then if I add these together, I get 5z, and I get 8, right? Now to eliminate this guy, I'm going to have to eliminate the x in the third equation. I'm going to have to multiply by a -4, right? -4 times x cancels this out. This is a -4. Y plus y gives me a -3y. Yep, -3y. And then a -4 times 3 is a -12, minus 3 is a -15z, and then -4 times 5 is a -20, plus 2 is a -18. So that's what I have so far. And then what's nice about this is I notice that these two, I can use this equation to eliminate the bottom equation. So the first equation stays the same, x plus y plus 3z equals 5. I'm going to keep the second equation the same. And then this plus that cancels out the y. I'm going to get, well, I'll just do the side work right over here. What's 5 minus 15? That's a -10z, right? And then this would become -10. 8 minus 18, -10. And we can see z is equal to 1. So if z is equal to 1, I can plug it into this top equation, and I can see 5 times 1 is 5. I subtract 5, I get 8 minus 5 is 3, and y is equal to 1. So now I know that I have x plus y plus 3z equals 5, and now I know y is equal to 1. I know z is equal to 1, and then using these two final ones here, I could put it up here. 1 plus 1 is 2. 5, when I subtract 2, 5 minus 2 is 3, and z equals 3. So now I know that z equals 1 as well. So I know that this ends up being true. So x equals y equals z, and my intersection point is the point 1, 1, 1. And there you go. So we were able to show through elimination that we have an intersection point, and that's what we want to do. Let's look at another problem, right? And it asks us to, example 49, show that the intersection of the planes below is a straight line. Find a vector equation of the line of intersection, right? So if I look at these two equations, I can eliminate any one I want, but it looks like the y's are going to be the easiest, right? So the first thing I'm going to do is take this top guy, right, and multiply it by a -2 to get the bottom equation. The first one's going to stay the same, so I know I'm going to have 3x plus 2y plus z equals 1, and then I'm going to have -2 times 3 is a -6 plus x is plus 7x is just x, right? And then the y's are going to cancel, right? Then I'm going to have -2z plus 5 is going to be plus 3z. And then -2 plus 3, that's going to be 1. So that's what I got. Now, to eliminate the other guy, I'm going to have to multiply, I can multiply the top by -3. And here, let's do this. I'm going to multiply the top guy by I want this guy to go away, so I'm going to have to multiply it by -3 and the bottom by a 2. Well, let's see. -3 times 9. A -3 times 3 is a -9 plus 10. That gives me x again, right? So that's going to give me x, right? So I got x. And then the y's are going to, this is going to be -3 times 2 is 6. 3 times 2 is 6. So it's -6 plus 6 gone. This is going to be a -3 plus 6 is going to give me 3z. So I got plus 3z equal to -3 plus 4, and that's going to give me 1, right? And you can see these two equations right here. If I eliminate them, it's going to be 0 equals 0, so this represents my line. So what I can do, here's one line I have. I have x plus 3z equal to 1. Now if I we want to find a vector equation of the intersection point. So if I let z equal some parameter lambda, some constant number, right, then I'll know that x is equal to 1 minus 3 lambda, right? So I know I have a parameter. I'm making the Cartesian equation. I've got my z is equal to some parameter, my x is equal to 1 minus 3 lambda, and then I can use these two to find out what y is equal to. So I'll go 3 times my x, which is 1 minus 3 lambda, plus 2y, plus z, which we let equal lambda, is equal to 1. And then I have 3 minus 9 lambda plus 2y plus lambda, and then equals 1. And then let's see, I got -8 lambda plus 2y. If I subtract 3, I get -2, and then 2y is equal to -2 plus 8 lambda, and then if I divide by 2, I get my y is equal to a -1 plus 4 lambda. So what do we have so far? I know that my x is equal to, what did I say? 1 minus 3 lambda. 1 minus 3 lambda. My y is equal to -1 plus 4 lambda. And my z, we just let it equal lambda. And we wanted a vector equation of the line, so the vector equation of the line is going to go through the point 1, -1, 0. Our parameter, alright, here we go. 1 plus lambda, and our vector is going to be negative 3, 4, 1. And there you go. So that's my vector equation line. Next. Last one, it says, example 50, show that the intersection of the planes is the empty set. So what does that mean? And it means it's going to be no solution. Does this mean that the planes are parallel? Explain. Well, let's look at this first equation right here. So it looks like I can easily eliminate this guy by adding them together. So I'm going to keep the first equation the same. If I add these together, I get 4x plus 3y. The z's cancel, and I get 4, right? Now, I eliminated the z's, so I want to eliminate the z's here, so I'm going to have to, I'll multiply the top equation by negative 3 to get the z's to cancel. So, let's see. Negative 3 times 3 is 9. A negative 9 plus 5 is a negative 4x. And then a negative 3 times 2 is a negative 6. Plus 3 is negative 3y. And the z's end up canceling. And then I'm going to have negative 3 plus 2 is equal to 1. Negative 1, my bad. So, and you can see by adding these two together, I can show that, you know, I have 3x plus 2y plus z equals 1. And then adding these together, I get 0 equals 3, which is, you know, no solution. Right? So it means, you know, the planes don't all intersect at a line or a point, right? It could be the situations we talked in the beginning of this video, but they had to ask us, are the planes parallel? And no, they're not parallel because look at our normal vectors, right? The normal vector for this one is 3, 2, 1. This is 1, 1, negative 1. And 5, 3, 3. So none of the normal vectors are parallel, so you know none of these planes are parallel. And there you go. Thanks, guys.